This question, n is given as the number of nodes in a full binary tree and height is given as h, and we have to find the relationship between number of nodes and height of a full binary tree. And it is also given that root is present at the level 0. Let us take an example. If height is 1, then here it is given that root is at level 0. So let us say this is root, and it is given that the tree is full binary tree. So if height is 1, this is root and it is present at level 0, and this is level 1. So this is the tree. Here the number of nodes is 3. Let us take one more example. Let us consider a full binary tree with height 2. So the tree would be this one. So this is level 0, this is level 1, and this is level 2, and root is present at level 0. So here number of nodes is, in the first example number of nodes is 3, and in the second example number of nodes is 1, 2, 3, 4, 5, 6, 7. So here number of nodes is 7. So if we generalize this, we would be getting n as 2 power h plus 1 minus 1. So here correct option is option D.
What is the LSB of the decimal representation of the hexadecimal number 7FFFFFA? So here the given number is in hexadecimal 7FFFFF and A. So this is base 16. We have to convert into, first of all, decimal. After converting into decimal, we have to find out what is the LSB, means here the least significant bit. Okay. So least significant position of the decimal number we have to find out. So if we convert this into decimal, we will get the value 21,474,83642. So 2 is the least significant position in the equivalent decimal. So option B is the right option here. In pure aloha, which of the following represents the channel utilization expressed as S in terms of the offered load G? Here the offered load is G and the channel utilization is expressed as capital S. Then what is the formula for finding the S in terms of G? That is the offered load. Options given are S2 G into e power minus G. Option B is S2 G into e power minus 2G. Option C, S is equal to G power 2 into e power minus G. Option D, S is equal to G minus 1 into e power minus 2G. There is a standard formula for the offered load in terms of offer load for the channel utilization, that is S is equal to G into e power minus 2G. Option B is the right option. Family of recursive languages is closed under 1. Union, intersection, reversal. So which of the, actually the three properties are given. One is the union, other is intersection, and other is the reversal. The recursive languages are closed under what? So here union is also closed because the union of two recursive languages is recursive. According to the closure properties of recursive languages, the intersection of two recursive languages is recursive, and also the reversal of a recursive language is also recursive. So all the three are closed under this recursive languages. So option D is the right option here. 8 Mbps token ring has a token holding time of 20 milliseconds. What is the longest frame that can be sent on this ring? So here the network is the token ring network and this 8 Mbps. So here the solution will be like this. So for 1 second, how many bits? 8 megabits. 8 megabits is 8 into 10 power 6 bits. 1 mega is 10 power 6. So for 1 second, 8 into 10 power 6 bits. Okay. So we can convert into milliseconds. 1 second is 10 power 3 milliseconds. For 10 power 3 milliseconds, it is 8 into 10 power 6 bits. For 1 millisecond, it is 8 into 10 power 6 divided by 10 power 3 number of bits. So it is equal to 8 into 10 power 3 bits for 1 millisecond. If you take the token holding time of 20 milliseconds, actually we need to find out the longest frame that can be sent on this ring. The longest frame means the number of bits that you can send in the token holding time. What is the token holding time here? It is 20 milliseconds. So in 20 milliseconds, how many bits we are able to transfer? That is 20 into 8 into 10 power 3 bits. So this is the number of bits we can transfer. So it can be written as 160. It is in the form of bits, but all the options are given in the bytes. 2 into 10 power 4 bytes, 16 into 10 power 4 bytes. So better divide it with 8 so that you will get in bits. 20 into 10 power 3 bytes, because 8 will be cancelled. So 20 into 10 power 3 is nothing but 2 into 10 power 4 bytes. 2 into 10 power 4 bytes of maximum frame we can have in this ring, where the token value holding time of 20 milliseconds and ring is 8 Mbps ring. So option A is the correct option here. Following statements is /r true. Three statements were given. Statement S1 is every proper prefix and every proper suffix of a string S is a substring of S. Statement S2 is every substring of a string S is either prefix or suffix of S. Statement S3 is CAO is a subsequence of string canon. So here we are having three statements. The first statement says that every proper prefix and every proper suffix of a string S is substring of S. So if you take epsilon, for example, if you take S is equal to ABCD, ABCD is a string, for example. For this, the proper prefixes are A, AB, ABC. These are proper prefixes. Epsilon is not a proper prefix. So every proper prefix is a substring, because A is substring, AB is substring, ABC is also substring. Statement S1 is correct. Similarly, if you take statement S2, every substring of a string S is either prefix or suffix of S. So this is wrong, because every substring need not to be prefix. For example, if you take S2, ABCD is a string, for example, here BC is a substring of S, but BC is not a prefix or BC is not a suffix. So every substring need not to be a prefix or need not to be a suffix. So here BC is not a prefix or a suffix. So statement S2 is wrong. Statement S3, CAO is a subsequence of a string canon. So it is correct, because CAO is present in this canon, so that it is the subsequence. Substring is different, subsequence is different. So S1 and S3 is true, S2 is false. So option D is the correct option here. The following statements is /r true. So two statements, we need to find out the true statements here. S1 is DES is one of the most popular public key ciphers. S2 is RSA is one of the most popular symmetric key ciphers. Actually, DES means it is data encryption standard. Actually, it is a symmetric key algorithm, most popular symmetric algorithm, but it is given as public key. Public key is asymmetric. Okay, RSA is public key. RSA means it is Rivest, Shamir and Edelman's algorithm. It is most popular public key cipher, but it is given as symmetric key cipher. So both are wrong. S1 and S2 both are wrong. So option D is the right option here.
Question. Node structure of a B plus tree is given. And the question is, a non-leaf node except the root node of a B plus tree must hold. Here 4 options are given, and we have to choose the correct option. In a B plus tree, all the non-leaf nodes must hold at least n by 2 pointers. Ceiling function n by 2 pointers, where n is the order of the binary tree. So this is the property of the, where n is the order of the B plus tree. So this is the property of the B plus tree. So here correct option is option A.